Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. What is normal reaction or what is normal force? These are the terms that we frequently use while dealing with the application of Newton's laws in dynamics. Consider two surfaces in contact. Say there is a block of mass m which is in contact with a horizontal surface. When two surfaces are in contact, because of the atomic interactions between these two surfaces, there arises a force So this contact force will fall into the category of electromagnetic force. Any electromagnetic force is a result of atomic interactions. In this case, it is the atomic interactions between surface of the block and surface of the ground which gave rise to this force, that is contact force. This contact force, if you resolve into two components, you get a parallel component and a perpendicular component or normal component. The word normal has arisen because of its direction. So this normal component of contact force is known as normal contact force. Point number one, this force arises only when there is contact between two surfaces. Point number two, the normal component of this contact force is known as normal force or normal contact force. Every time we don't use the word contact. So the reason why we call it as normal force is because it is normal to the two surfaces which are in contact. Then the parallel component of this contact force is known as friction. So basically, normal force and frictional force, these are two components of the single force which is known as contact force, which is electromagnetic force, one of the four basic forces in nature. And if you observe, normal force is always directed perpendicular to two surfaces in contact, and it is always directed in the direction of push. Because two surfaces in contact can only push each other, they cannot pull each other. Right? Suppose if you place a block on the ground, block pushes the ground and ground pushes the block. It is not possible that the block is pulling the ground or vice versa. A contact force is always in the direction of push and it is perpendicular to two surfaces in contact. So this video is dedicated to normal contact force. I am not talking about friction. So the way how friction works is a completely different story. But coming to normal contact force, so if two surfaces are in contact, say the block is in contact with the ground, block is exerting normal force on the ground. So this is normal action. As a reaction, ground exerts a force in the upward direction because upward is the direction of push. The ground is pushing the block in the upward direction with a normal force n. So this is normal reaction. So normal reaction is the effect of normal action. It's like both the surfaces are pushing each other. Now let us take a couple of examples. Say in the first case, there are three blocks placed on each other. So now, if you draw the free body diagram of M1, I'm only talking about the normal force. Normal force on M1, there is normal force by ground in G, and there is normal force applied. So this is normal force applied by ground, and M2 is pushing M1 down. So the normal force is, let me call it N1. N1 is the normal force exerted by the surface of M2 on the surface of M1 because both are in contact. Most students are confused here. They think the weight of M3 is acting on M1 and there is also normal contact force between M3 and M1. No, these are all misconceptions. Normal force exists only if there are two surfaces which are in contact. M3 and M1, there is no contact, so forget about normal force between them. There is no normal contact force between M1 and M3. It is only between M2 and M1, M3 and M2, and M1 and ground. So these are the normal forces. Now if you draw the free body diagram of M2, there is normal force applied, say N2, by the block M3, it is pushing down. So basically M1 is pushing M2 up, so M2 is pushing M1 down. If I call this N1, this is normal action, this is normal reaction. M3 is pushing M2 down, normal action N2, and I have normal reaction N2. Equal and opposite forces. So on M2, what are the normal forces acting? There is N2 down, applied by M3. There is N1 up, applied by M1. Similarly, if you draw the free body diagram of M3, there is normal force N2 applied by M2. So this is the only normal force acting on M3, because M3 is in contact with only M2, whereas M1 is in contact with two surfaces, ground and M2. M2 is in contact with two surfaces, M1 and M3. But M3 is just in contact with M2. There is only one normal force N2. If you take an inclined plane, the block is exerting normal force. So as I said, normal force is perpendicular to two surfaces in contact. So this is the surface, the common surface in contact. So M, the block is exerting normal force perpendicular to it. This is normal action, and the inclined surface is exerting a force N in the direction of push on the block. So this is normal reaction. So on M, this is the normal force. With a dotted line, I'll represent the surface. Surface is making angle theta. This is theta. Normal force and surface, they are perpendicular. This is 90 minus theta. So this would be theta. The direction of normal force applied on the block by the inclined plane is at an angle theta with a vertical. This is the normal force or normal reaction, which is the effect of normal action. So this is all about the normal contact force. Thank you. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.